Good evening, one and all. Myself, Dr. Chevella Anil Kumar, working as an assistant professor in the Department of ECE at VNR Vijay ITE, Hyderabad, Telangana, India. Today, I'm going to explain about my research topic analysis of human emotions through speech using deep learning fusion technique for Industry 5.0. So, the main content I'm going to cover in these presentations are introduction and importance of research area, motivation of the research, statement and objective of the research, literature survey, the proposed methodology and technologies used for emotion recognition, and then data sets, and then results and analysis, conclusion and future scope, and then references. Introduction. As we know, the communication is a fundamental ability which is based not only on linguistic statements but also on the emotional part. Hence, it has become an important issue to identify the user emotional state. Right? Generally, emotion is a mental state associated with the nervous system, right? Brought on by chemical changes variously associated with thoughts, feelings, behavioral, and responses. The general emotions are neutral, anger, disgust, fear, happy, sad, and then surprised. A human possesses a natural ability in understanding different emotions, right? So to convey the information through emotions, we have a different types of biometrics like facial expressions, speech, and then gesture. So like that, mainly the facial expressions and speech signals play a major role in expressing the emotions. Emotions helps us to understand each other better, and natural outcome is to extend this understanding to so then generally what is meaning by emotional regulation? It is the process of identifying human emotions most typically from verbal or non-verbal communications. So coming to verbal communication, we are going to consider as a speech. In non-verbal verbal communication, we have a facial expressions, body languages, and gestures. Right. The main motivation of this research area is, as we know that detection of emotions without the intervention of human beings has become an important area of research. Mainly in the COVID era, the human computer interface plays a research strength to identify the human emotions. For example, the conversation between the student and teacher in online classes, and the conversation between doctor and a patient for online consultation, and then robotic services. So effective computing claims that emotion detection is necessary for machines to serve better in their purpose. So it has many applications, and emotion detection is a challenging task because emotions are subject. Yeah, when coming to in our research, we are going to consider as a speech as a one of the biometric to recognize the emotions, right? So speech is the one of the most natural and common ways that people communicate with each other. So that's why we are choosing our problem statement as a emotion recognition from speech. So it provides a rich source of information about the speaker's emotions, attitude, and intent. And the emotion is mainly depends upon like implicit paralinguistic and linguistic content, speaker variability, context dependency, multimodality, cultural differences. So the main problem statement and objectives of our research is, so previously the research has shown that over 90% of our communication can be verbal or non-verbal, but technically has struggled to keep up. So there has been a rise in interest in identifying the emotions from facial expressions or speech data, which has led to the development of novel computational methods and methods of analysis to identify the emotions from the speech. Traditional methods is generally bad at understanding of our intonations and intentions. But now we have to thanks to advanced version technologies like deep learning to extract and understand the human emotions more accurately compared to machine learning and other AI algorithms. So the main objective of this research proposed quantitative correlated based emotion recognition system is to make the human to machine or machine to machine or human to human interaction more natural and then effective. So in order to perform this task of emotion recognition from speech biometric, so we propose to use customized fusion based deep learning networks to achieve better recognition and classification or accuracies. So this is the literature survey. So I didn't focus main on the review. I will focus on my proposed methodology. So like if you go with early traditional methods aim to design handcrafted features manually inspired by psychological and neurological theories. The modern deep learning methods outperform traditional computer vision methods. Like if you see before 2014, we are going to use the traditional computer vision methods. In that we have to extract the features by hand. That is handcrafted features we need to extract by the user. But if you consider after 2014, the deep learning concept came to exist for AI emotion analysis. But since 2020, the advanced version of deep learning method, that is specialized neural networks for emotional analysis, came to exist like CNN, LSTM, and then combination of CNN, LSTM, etc. So the flow diagram or the block diagram of our proposed methodology is first we need to collect the database, and then after that we need to go with the pre-processing to convert the unstructured data to structured data in order to apply for the our proposed DL model, that is deep learning models. And then for that we need to design our customized deep network model, and then we need to train that network model, and then finally we need to test our proposed model, and then after that we need to fine tuning our model based on the results in order to increase the accuracy and then efficiency of the. And in this proposed methodology, we are going to use that we have used RAVDESS dataset that is contain around 1440 files with 16-bit and then 48 kilohertz specifications. These dot wave files are recorded by the 24 professional actors. There they are having 12 female and 12 male humans, and each person is recorded with 60 trials for each emotion. That is around 1440 wave files we are having. So this dataset contains mainly the following emotions like calm, happy, sad, angry, fearful, surprise, neutral, and disgust expressions. And this Dravidian dataset is recorded with using the following sentences called as kids are talking by the door, dogs are sitting by the door. These two sentences are used for recording the dataset with a different emotional. So these are some of the examples of the databases, the raw.wave file and the corresponding spectrogram. The first one is for hungry and the second one is for fear. So this research suggests that in order to develop a system that can accurately recognize emotions expressed through speech, it is important to learn and extract relevant features of the input data. So in order to achieve this proposed research, we proposed a use of hybrid deep learning model. That is nothing but, so we have a CNN model and then the LSTM model separately. But in our proposed research, we need to combine that CNN plus LSTM in order to extract the local and global features of the input data set. So that is, we are going to use fusion based or hybrid model of deep learning, that is CNN plus LSTM. And also we are going to take input data as either one dimensional data or two dimensional data. For one dimensional data, we are going to give the raw speech file as an input. For two dimensional data, we are going to use like MEL spectrogram as the input data to our proposed SCR-DLNet model. Here, the SCR-DLNet model is nothing but the coined name of the proposed model, that is nothing but speech emotion recognition deep learning network model. So this is the overall block diagram internal block diagram of the proposed SCA DLNet. Here we are going to use input either AC is nothing but raw audio clip or log mil spectrogram, that is two-dimensional data. And then for that we are going to use CNN. That CNN is consisting of like LFLB. The LFLB is represented as a local feature learning block. That is CNN is going to use for the learning the local features, and LSTM is going to use for the learning for global features. Then after that we are going to give as a fully connected layer to classify the emotion. Each emotion like angry, surprise, disgust, fear and happy, neutral and sad. And each LFLB block consisting of convolution layer, batch normalization layer, LU activation function and then max pooling function. So it is complete structure with the specifications of the data set at each layer. Like if you are going to take a input as an either raw speech data or mil spectrogram data. So first LFLB. So in our proposed model we are going to use two types of models for each LFLB. Like first we are going to take in as a 4 LFLB layers plus LSTM layer. After that we are going to extend the structure as 6 LFLB layers and then followed by LSTM layer, and then we have tested the results for that. So this is complete data complete architecture of the our proposed network model. So the proposed hybrid network model were made with 4 LFLBs and 1 LSTM layer, as well as 6 LFLBs and 1 LSTM layer for both one-dimensional data or two-dimensional data. And this proposed hybrid network model compared with the one-dimensional individual. So our proposed model is also compared with the only one-dimensional CNN or two-dimensional CNN without an LSTM network for the RAVDESS database. So as I said, first we need to collect the database. After that we need to pre-process the data file. That is, we need to convert into unstructured data to structured data. For that we have used that pre-processing the in speech files. That is, the raw audio files are converted into 16 GB, 16 kilohertz frequency with 1,28,000 bit vector. And also we are going to use the FFT window length of 2048 and the hope length is 512, while the log spectrogram is being computed. In this process, as a result, a log mil spectrogram is constructed with 251 frames and 128 mil frequency bits. So finally, a 128 by 251 matrices were used as an input to the two-dimensional hybrid network. So here we are going to give as a specifications of the CNN either for one-dimensional or two-dimensional. This is without using an hybrid model. Only CNN model we are going to use for identifying the emotions. So for this individual 1D CNN, if I use one-dimensional CNN, I'm going to get 85.47% accuracy for RAVDESS database. If I go on with the 2D CNN, I'm going to, so somewhat the accuracy is going to increase that 88.36%. Okay. And then these are the corresponding confusion matrices for 1D CNN and then 2D CNN without using an LSTM layer. So these are the metrics or accuracies are achieved for our proposed model for 1D CNN plus LSTM. That is, in 1D CNN plus LSTM we have tested the network with two types. That is, first using 4 LFLB layers plus LSTM. After that we are added 2 more layers to the existing model, that 6 LFLB plus LSTM layer, and that proposed model is trained with a different number of epochs, and then we have recorded the accuracies. So for that, for around 300 epochs we are going to get better accuracy for both LFLB, 4 LFLB and then 6 LFLB plus LSTM layer. But the highest accuracy we are achieving compared to this 4 LFLB plus LSTM layer and 6 LFLB LSTM is 91.51% for 6 LFLB plus LSTM network. Similarly, the same process we did for 2D CNN plus LSTM also. Here also we are going to get higher accuracy for 6 LFLB plus LSTM. But when compared to 1D CNN plus LSTM or 2D CNN plus LSTM, we are going to get the better accuracy for 2D CNN plus LSTM. So these are the accuracy curves for 1D CNN plus LSTM and 2D CNN plus LSTM with two different types of networks, that is 4 LFLB plus LSTM and 6 LFLB plus LSTMs for both 1D CNN plus LSTM and 2D CNN plus LSTM. And this is the confusion matrix for 1D CNN plus LSTM network with 6 LFLB plus LSTM internal architecture. That is, for this we are going to get that accuracy is 91.5% and precision is 91.62% and recall is 91.49%. Similarly, for 2D CNN LSTM, we are taken for 6 LFLB LSTM layer confusion matrix. Here we are going to achieve that accuracy is 95.5%, precision is 95.61% and recall is 95.65%. And also in result for analysis purpose, we are compared our proposed models either 1D CNN plus 2D CNN networks with individual CNN layers, that is 1D CNN and then 2D CNN. Finally, we are going to get that better results using two-dimensional CNN plus LSTM layer. Okay, that is 95.52 accuracy, 95.61 precision and 95.50 recall. Similarly, and also we are compared our proposed model with existing literature. By the literature, Weijing et al. Proposed a deep learning network model only, but he has achieved only 64.48%, and Mjala et al. Done the emotional analysis on RAVDESS dataset only, but he achieved only 69.40%, and Mohammed Sajid et al. Worked on same RAVDESS database only, but he is getting only 91.14% accuracy. But our proposed model is achieved that 95.52 accuracy and 95.61 precision and 95.50 recall. So finally, in conclusion, in this research, we propose a customized deep learning network model, that is SCR-DLNet, that is speech emotion recognition deep learning network, to recognize the emotions from speech biometric. So we trained the proposed model on the RAVDESS dataset for speech emotion recognition, and we observed that complex emotions were more challenged to classify, resulting in unsatisfactory result. So in this research, we found that the performance of the deep learning network model is greatly influenced by the structure and hyperparameter of the network model and also the database we use. So we also observed that some of the more complex emotions were misclassified and produced unsatisfactory results. So in order to improve this recognition accuracy, we reconstructed the network model by modifying network hyperparameters and retraining it several times with most confused emotions of dataset. So furthermore, we applied the early stopping technique to prevent overfitting and underfitting of the network model, which led to an increase in proposed network accuracy. So proposed emotion recognition model achieved an accuracy of 95.5% on RAVDESS. So when coming to the future scope of our research is, the proposed model for speech emotion recognition can have several future applications in the field of education, healthcare and entertainment. However, as pointed out, the limitations of this research are related to the lack of sufficient data in emotional speech database. So to further improve the proposed model, the future research can focus on increasing the diversity and size of the emotion databases used for training the models and optimizing the algorithms and exploring the new approaches. So these are the some of the references we use for our proposed research. And thank you so much.